Install the antennas correctly in electroculture is crucial. There are a few key nuances to consider to prevent mistakes that could lead to your antenna not functioning properly. To begin with, it is important to check if there is proper insulation on the support. Without insulation, various issues may arise. For instance, if you have 3 antennas without a screw relation to the support, it means that the antenna is directly attached within the support, whether it is a tube, a piece of wood, or a metal rod. It is essential to have insulation between the antenna and the support to ensure proper functioning. Different materials used for both the antenna and the support will have different effects. For example, using an all-copper antenna on a copper tube allows the mass of the tube to serve as an electron reserve, facilitating the flow of current. On the other hand, using an aluminum antenna on a piece of wood requires a conductor to ensure the current flows efficiently. In cases where a piece of wood is used as the support, it is recommended to place a piece of EPDM-type tarpaulin or plastic sheeting between the antenna and the wood. This prevents electrons from breaking down the wood and ensures a secure connection to the ground. In the past, insulation was placed between the antenna and any metallic parts or wood supports. For example, Justine Christapel used bituminous tar for this purpose. Using scrap metal like a ferriter as a support can lead to rusting, which may impede the current flow. While using iron rods as supports is cost-effective and convenient for mounting antennas at great heights, it is still advisable to include an electrical cable connecting the antenna to the ground. This grounding ensures the safety and efficiency of the setup, especially when dealing with low currents in the milliamp range. In case the current flows poorly with surface rust already being observed, small nuances like this on these antennas are very simple to manufacture. Either way, that's what she had created. We just liked them by extra, and now we saw others how to perform without insulation to support the current. It's not the same. You understood it well if it goes through the wire or if it goes directly through a tube. The copper tube adds mass, adding more electron reserves. I repeat, what often makes you will already make a difference in potential with Earth, but the tube will charge itself. It will make a reserve that will be able to exchange electrons with the atmosphere or with the ground, depending on electrical variations in the weather. I think it's better to use a tube than a wire if you have the option. Let's imagine in a vegetable garden or a small space you want to connect a single antenna. Let's imagine it's better to think of the tube as the wire. Then the insulation supports the insulation support. Here, if we are going to do antennas that go up very, very high, the highest possible being 7 meters, 10 meters, 20 meters, it will work with a wire. Here you see on the left, the wire allows you to connect antennas very high, as I just said. While the tubes, like that full tube, we will have, it's hard to have a full copper tube go up to 6 meters, 10 meters, 15 meters, 20 meters. You will have 4 meters tubes, for example, 5 meters. This will be very good for small heights on air. But as soon as we want to go above, you will have to call on support insulations to mount higher to get the high voltages, be on the highest point of the field, and capture as much electricity as possible during weather forecasts. And now, you see me with an M flag, 2 antennas put at the top. We will move the wire down the inside of the M, isolated, and then it will be connected to the plot of culture. The antenna is at the top, support insulation. What is it, and what party? We've already seen it a bit previously, but the information is also the rehearsal is the part here. You can see we have our copper tube, and on the copper tube, we have some kinds of collars that have an insulating part, plastic on the inside. That makes me repeat, look at the plastic. It is in contact with our antenna, so it isolates it. What makes the current go through the wire, the antenna in pink, is isolated from my gray support by the good insulation systems in yellow, a support insulation that makes the running go where we want. Going to go by the electrical wire, it is that way he goes. Circulate attention when you connect your electrical wire to your antenna so you can then connect it to the crop plot. You have to put on, I recommend putting the wire against the copper tube. Tighten the copper tubing as much as possible. You can even imagine doing 2 full turns of the tube and clamp the copper with the stripped wire. Ensure that the bolts make enough contact and hold up well. The contact you see here is enough for the current to circulate. The mistake not to make is you should never let your copper wire touch the support insulation systems because it affects the systems. You don't need anything but your copper wire to touch the support insulations, then you are fine. As I said, I recommend adding electrician's Scotch tape around your stripped copper wire for additional protection. It is not mandatory, but it allows you to have the protection of your cable fixing system where the current will flow. Put on electrician's tape. It allows for better isolation. These antennas can be erected with insulation support up high on wooden posts, for example. It is a good idea to have one antenna per row. I have placed one on each pole. One per row would suffice. If you have access to scrap metal, you can make your antennas. The antenna is fixed against the end of the wood, and the electrical wire in blue connects the antenna wire to the ground with the bare red copper cables, for example, or wire galvanized or aluminum wire. There are plenty of options for experienced individuals who are in the know, and therefore the current circulates between the ground where the red wires are and the antennas on the dots. Turn up the blue wire, and there are the red wires. Here you have a flagpole made of aluminum. The advantage is that it is light, very resistant, and designed to withstand storms. It is quite aesthetic, with a scabbard at the base that you push into the ground. To insert your flagpole into the base, fit it into the scabbard. This scabbard also allows you to remove it. The antenna can be easily removed in 30 seconds. Simply take it out of its support and place it on the ground. In the event of a major storm, you should be able to quickly remove your antenna. It's a good practice to lower your antenna annually to conduct a brief check of the connections. Ensure everything is in order, measure the electrical conductivity, and make any necessary adjustments. To facilitate easy lowering, the antenna is constructed with multiple tubes that converge into one to form the shape of an M, with the antenna positioned at the top. This design allows for adaptation. For instance, an antenna adapted onto an M shape can be seen here. The M shape is fabricated with holes, as shown by the blue arrows, where I have drilled holes to insert threaded rods with bolts for reinforcement. Rings are affixed at the top, bottom, and middle to secure the antenna in place. This robust setup ensures the antenna's stability, durability, and insulation. It's crucial to keep antennas away from flag poles and high-voltage power lines to avoid any risks of electrocution. When mounting antennas, ensure they are placed on high points without any tall trees nearby. The antennas should be the highest points in your garden. In the illustration, there is an antenna on the left and another on the right, both made of copper tubes to allow current flow. Directly through the copper tube this time, we're going to use the difference in mass of the tube, which is a reservoir in electrons. You have an antenna, all aluminum here, which will simply be inserted in the copper tube. That is to say, your aluminum antenna has a diameter slightly lower than that of the copper tube, which allows us to insert it in a permanently fixed way with very good electrical contact. Then, you can simply place your antenna, open the sprigs, and place them in the vegetable garden on small plots or crop plots. In this way, it will be very effective. To finish, of course, do not forget to open the wires of the antenna. Do we receive it or do we get it made with the straps that are closed? Then, we will, of course, open them to have the largest surface area of contact with the atmosphere. The spikes are doors of entry and exit for electrons. That's it for the small technical details you need to know about aerial electroculture antennas to put them correctly. I will continue in another module. Thank you.